are interested in graphing linear equations, using the slope-intercept method. Notice this tends to be one of the more straightforward ways of describing a line. We notice that a positive slope is thought of as being a line that goes up as we move from left to right. A negative slope goes down as we move from left to right. A slope of 0 is a horizontal line. And then a line with vertical slope also called undefined slope, unsurprisingly, is a vertical line. So, pretty straightforward. So, to determine the slope of a line, to determine the slope of a line, through points P1 given by x1, y1, and P2 given by x2, y2, we know that we use the letter m to indicate slope equals y2 minus y1 divided by x2 minus x1. And we notice this is really just the vertical change divided by the horizontal change. You also notice the choice of whether to put x1, y1 first or x2, y2 first doesn't actually matter. We notice we'll get the same thing if we took y1 minus y2 divided by x1 minus x2. We notice that we just have to have the coordinates match. We want to make sure that the 1's match and the 2's match, but the actual order doesn't matter that much. We notice that if we mix and match, we'll get the exact opposite of the slope. And obviously, if we tried putting x's in the numerator, y's in the denominator, we'll get the reciprocal of the slope. And so we'll see a few examples of that in the homework. So if we look at the slope of the line joining 3, 4, and let's make it 1, negative 2. We notice we can calculate the slope. M is going to be negative 2 minus 4 divided by 1 minus 3. We notice that we take the y2 minus y1 divided by the x2 minus x1 and we get negative 6 divided by negative 2, which gives us positive 3. And if we had said instead m equals 4 minus negative 2 divided by 3 minus 1, we would have gotten 6 divided by 2, which is still positive 3. So then we notice that we've got the slope. Next thing we're interested in is the intercepts. We notice that if we write an equation in the form y equals mx plus b, this lets us know that we know the slope is m, and we just think of that as vertical change divided by horizontal change. And that's often referred to as rise divided by run, or rise over run. And b is the y-coordinate of the y-intercept, the point at which the line intercepts the y-axis. And we notice the x-coordinate of the y-intercept is, by definition, is 0 by definition. So if we wrote y equals 2x plus 3, and we want to graph that, we can just draw the coordinate axes. We find the point 0, 3, and then we know the slope is 2, so we can either go up 1, 2, and over 1, and get that point, or we can go down 2, back 1. And the idea of that is we can think of the slope as either being 2 divided by 1 or negative 2 divided by negative 1. So we think of the rise over run as being positive 2, positive 1, or negative 2, negative 1. So up 2 over 1 or down 2, back 1. Then we have to be careful. If we had y equals negative 1/3 x plus 6, we notice that we would wind up getting our y-intercept would be at 0, 6. And now we can either go down 1 over 3, or up 1, back 3. And so again, we get that straight line, and again we notice that a positive slope goes up as we move from left to right, negative slope goes down as we move from left to right. So we also notice that if we were going to look at something like 3x minus 4y equals, make it 12, we notice that if we set x equal to 0, we notice that we're going to get a y-intercept. We wind up seeing that negative 4y equals 12, and so y has to be negative 3 if x equals 0. We get y-intercept of 0, negative 3. Now, how do you suppose we get the slope? We notice that we can manipulate this equation pretty nicely if we look at that 3x minus 4y equals 12, we can subtract 3x from both sides. We see that negative 4y equals negative 3x plus 12. If we divide both sides by negative 4, we're going to get y equals positive 3/4 x minus 3. And so we notice that our slope is going to be 3/4, and our y-intercept is going to be at 0, negative 3. So if we graph that, we notice that we would find our y-intercept is 0, negative 3, and then we can go up 3 over 4, or down 3, back 4. So again, nice and neat. So we'll do a couple examples of that. We notice that if we're given y equals negative 2x plus 6, and we're going to graph that, again, we're going to look for the y-intercept, 1, 2, 3, 4, 5, 6, and then the slope is negative 2, so we can go down 2 over 1, down 2 over 1, down 2 over 1. And so you notice in this case, because of the way the graph was arranged, it was more convenient to just keep going with values of x increasing instead of trying to go backwards. Given y equals negative 3/5 x plus, let's make it negative 6. Just to be a little bit different. So if we have y equals negative 3/5 x minus 6, now we're going to notice that our y-intercept is at 0, negative 6. And now we're going to go, if we go up 3, 1, 2, 3, we have to go back 5. If we had gone down 3, then we go to the right 5. If we're not given the equation in slope-intercept form right away, we notice that, as we saw in that previous example, if we had 2x plus 4y equals, let's make it 8, we notice that we can always solve for y. We can subtract 2x from both sides. We get 4y equals negative 2x plus 8. We can divide both sides by 4. We get y equals negative 1/2 x plus 2. And so, relatively nice and neat to graph. We find 0, 2. And we notice that if we go down 1, we have to go over 2, up 1, back 2. We also want to be careful if we had something like, let's make it 2x plus 2y, like a negative 2x plus 2y equals 4. We notice that we can add the 2x to both sides. We get 2y equals 2x plus 4. We divide by 2. And we'll get y equals x plus 2. We remember that if we don't see a coefficient, we can think of it as being a coefficient of 1. And in particular, we think of it as being 1 divided by 1. So we notice that we're just going to get a y-intercept of 0, 2, and then the slope of 1 means that we can go up 1 over 1 or down 1 back 1. So similarly, if we had y equals 4x minus 2, we notice that we would find the y-intercept is 0, negative 2. And we could go up 4, 1, 2, 3, 4, over 1, or down 1, 2, 3, 4, back 1. So if you have a whole number slope, we can always think of that as being, the slope is that number divided by 1. We can always think of that 4 as being 4 divided by 1.